Let's get going. Welcome, everyone. Let me just get things finished setting up here. It's going to be a very early morning stream. Yes, it literally just started. And tonight, this morning, I'm going to be attempting to hunt for Artemis 2. And I'm going to start this off attempting to do this using coordinates that I computed for Artemis 2 based on the orbit that I measured from the first night's observations. And then I loaded that as a TLE file into Orbiter Spaceflight Simulator and did my own little simulation of what the translunar injection burn should look like to have a free return trajectory. And then I took the output of that to give myself an approximate position of where Orion should be, and now we're going to hunt for it. So, let me just pull things up here in SkySafari Pro. Looks like we are. Let's see. Okay, I'm pulling this up in SkySafari Pro so I can see about where I am. And let me astrometrically solve one of these pictures to get my bearings. So what I'm going to do, turn up the volume. Okay, I'll do my best here. Okay, how's that? Tell me if I'm too loud. Turned up the gain. Okay, let's see, that bright star is HD 144690. Okay, see. Now what I'm going to do is look at SkySafari, see if there's anything here that shouldn't be here. Anything here moving? Blank frames. Nope. So let me show you guys. Let me add another source. Oh, sorry for the glitchiness. So there's a blink comparison. Now, there... Oh, I didn't mean to turn up the volume on my phone. Now, there is field rotation because, once again, I'm using the 11-inch in altitude azimuth mode. I want the full power of the 11-inch telescope, and I've had to stick it way off in the corner of my property where I wouldn't be able to polar align anyway, so... But I'm not seeing anything here, so we'll move on. We'll try a new set of coordinates. So I will move to about half a degree down. I've had to pulse the telescope about 3 times down to get the stars to really land in the center of the CCD. I aligned with an eyepiece. The CCD is looking a little bit below where the eyepiece looks, so I'm trying to compensate for that manually. Okay, so now we have a new field of view. Now, Orion should be moving pretty slowly through the sky. And this area of sky has just come up over the tree line, so hopefully we find it before dawn. All frames. So once again, blinking frames, looking for anything that moves. Now we got a few frames a little further apart. So blinking these. There's some field rotation, but I don't see any obvious objects moving relative to each star. Now I'll move the scope over. can see the stars streaking as I've moved the scope. Wait for the tracking to settle down. Did I take these pre-TLI? I took the first set of images pre-TLI on the previous live stream I did. These are all live images you're looking at tonight. I'm taking them as we go. Yeah, so the streaks just now were from me moving the scope, but... Okay. So the tracking's settling down. Didn't need to move the microphone there. And I'm running 20-second exposures again, same as the other night. 2x2 binning, so enhancing sensitivity, reducing resolution, and sacrificing color data. Make sure I have my bearings straight here. I'm gonna upload this latest picture. Blinking those frames. Okay, astrometry says we've got HD 144786 at the extreme right of the field of view. HD 144786. Check out. Oh yeah, I see the field of view. Okay, I don't see anything moving, and looking at the star pattern, I see these stars seem to, at least all the ones I can tell, looks like they're all in Sky Safari. No unusual objects that I can see. Okay, so we will then move on to the next field of view. Going to move it about 20 arc minutes south again. Okay, right ascension 16.8 at minutes, 29 seconds. Declination negative 26 degrees, 50 minutes, 13 seconds. Go target. Slowing scope. So now the scope's moving. This exposure will be streaked. Pulse it 3 times. Okay, now the expected field of view should be entering the entering the field of view of the scope. Okay, wait for the tracking to settle down. Okay, tracking settled down. I will solve this image. Throw that up to astrometry.net. See what we got. And load that into SAOmage DS9 so we can do blink comparison in a minute. Where am I compared to day before yesterday? Still in the constellation Scorpius. Same constellation, just a different area. Okay. Let's see if astrometry is done yet. It is. Okay, what do we got to work with here? We have HD 144808 is the bright, somewhat bright star just left of center. Let me pull that up in Sky Safari. HD 144808. Okay, got it. Okay. See if I can blink some frames here. Okay, not seeing any super obvious movement. Let me grab just that latest image frame. Okay. Frame 53, blank those. Yeah, everything looks like it's rotating / moving in the same direction. Okay, so we will move the scope. And shifting scope. Oh crap, my phone fell off the table. I'm on a steep incline here at the edge of my property. Suboptimal. Phone's okay, thankfully. Okay. I'll wait for the tracking to settle down again. Settle down. Any day now. Backlash in these gears is a little frustrating. There we go. That's more like it. Okay. Frame 59. I'll throw that up to astrometry. Will we actually be able to see it since it's 150,000 plus away? Hopefully. That's why I'm pulling out the 11-inch. That's one reason, like I said. I want as much aperture as possible. It is going to be quite far, but this telescope is considerably powerful. Okay. Star HD. Okay, same star HD 144808 is now at the extreme right edge of the field of view, so we're spanning a bit. Okay. Let's see. Frame 62. Blink. Oh. Blink. Okay, 59 versus 62. Not seeing a whole lot obvious, but 62 is kind of blurry. Let's see. 65 looks good. Let's try that one. Or 64, I guess. Frame, blink frames. That's better. Yeah. So looking at the blink comparison. Some field rotation, stars shifting as the field rotates under ALTAS tracking, which does make things a little more difficult, but I don't see any sign of Orion here. Okay, moving on. Single frame. Turn that off for the moment. Clear frames. The blink comparison. Oh, and SAOHDS9 crashed. That's fun. Let me fire that back up. And in the meantime, let's go to a new set of coordinates. Okay, we're gonna go for a new set of coordinates. Okay, we're gonna go another 20 arc minutes south, roughly. 27, 10, 13. Okay, it's gonna streak this exposure, that's okay. No, phone, don't fall off the table again. Pulse 3 times. Down. Okay. I'll wait for the tracking to settle. upload to astrometry. Let's see if we can find out where we are. Confirm where we are, really. Okay, that's a good frame for reference. Okay, we're right on the mark. 1608.29, negative 2711.04. Astrometry's not pulling up the annotated image, but the coordinates are a match. So that's good. Come on. Pull up the annotated image, please. There we go. Okay. HD 144941 is top left corner. Pull that up in Sky Safari. Okay, get that reference. Single frame. Okay, that last one was pretty blurry. Maybe we can get a good one here. Okay, that looks good. Okay, blink frames. Quite a bit of shift. So there's the blink comparison. Okay. I blink frames that are a little closer together so we get less total shift. Still don't quite see anything I'm confident on. Okay. Let's move the scope. Wait for the tracking to settle down. Let's see if we can astrometrically solve this. Yeah, if I catch it, then I can solve for the orbit and continue to track it on successive nights. This TLI burn was quite a big maneuver, so trying to simulate that in Orbiter Spaceflight Simulator to catch up to it is tricky, to say the least. Okay, I've got the solution. HD 144941 is now just at the near the top right of center. Okay, let's see, it's clear frames. And set for blink comparison. I don't know why it's scale's making me a little hard to see. 1413. Let's do this. Log scale frames 1413. There we go. Oh, I see. That's why I'm not making heads or tails of where I am relative to the live images because I forgot to reorient them. For some reason, SAO Image DS9 wants to flip the images, and I have to re-invert them to get them to be the same orientation as CCD Soft. Okay, now when I look at CCD Soft, it's the same. Okay, now I can compare it to my Sky Safari. Ah. Oh, look at that. What's this? Almost dead in the center. Something's moving. Heck yeah. See that? highlighted in green. Okay. This right here. Almost dead in the center. Okay. Hold on, I'm going to abort on that. I'm going to change the name of this. This is going to 1, 2, shit. All right, start taking pictures. All right, let's go back to blink. Yeah, it's moving relative to the stars. It's kind of above. Kind of above that bright thing there. Okay, let's add a third frame, see if it continues moving in a consistent direction. Scale parameters, 1413 for the dark value. Okay, let's see, should be about here, I think. Frame, blink frames. The whole thing shift. The telescope's tracking is shifted a bit. Single frame. Alright, let's delete that. Let's delete that. Frame, new frame. Open. Scale 1413. Blink frames. Yeah. Yeah, I think it's moving. It's definitely moving. Okay. So let me see. It's about here, I think. Okay, this is going backwards in time on the blink comparison, but highlighted in green. It's kind of a reverse time lapse. You can see how it's moving relative to the stars. Ladies and gentlemen, I think we have Orion. Right here. Do I think they'll crash into the moon? No. But the fun thing is, with these images, we can independently solve for the orbit, confirm it's Orion, confirm it won't hit the moon. And frame, single frame. I should, at this point, it's so far away. I should be able to command a telescope somewhere else in the world, hopefully, if one's available right now, to confirm via parallax as well. Let's see, T-72 is available. Oh, yes. Gimme. Okay, reservations. Are there any reservations coming up? 40 minutes. We can do that. It's moving slow enough. Hopefully the parallax isn't so great it puts it completely out of the field of view. Get info. I'm gonna solve one of the latest images here. So I can get the coordinates. Get info, coordinates, WCS. Okay, let's feed that in to the telescope in Chile. And hopefully the field of view is wide enough to capture it despite the parallax. 2x2 binning, luminance, 5 minutes. Acquire images now. Run started successfully. Fingers crossed. Fingers, toes. Oh, appendages crossed. It's slewing over there now. In Chile. Yeah, it's already moved over here. Gotta keep up with my cursor. Yeah, I have access to other telescopes around the globe through itelescope.net. How do I know that one point is the capsule? Because it's the one that's moving. Zoom more. This is incredibly zoomed. But no matter how much I zoom, you're never going to see it as more than a point-like light source. If I was resolving the shape, well, that would be a problem. There's no way something this far away should be resolvable as more than a point-like light source, even to a professional telescope at that distance. Which dot is the capsule? It's the one with the little arrow pointing to it. Yeah. The white dot. Yeah, that's it. Now, I did invite someone who is skeptical, shall we say, that this mission is real to come join us tonight and remote control my scope and see for himself that I'm not faking it. But he said he was going to be in bed at 4 a.m. and would not be joining us. So it's only now turning to 4 a.m. and I don't think he'll be joining us, but that's okay. We'll keep tracking this until dawn. Show the moon with this telescope, then I will believe you. Well, I want to get some valuable data here on the capsule before dawn. Maybe once we're done with the capsule, before I sign off, I'll point it over at the moon and try to run a very short exposure so I don't blow up the camera. Let's see the moon. We'll see the moon when it's all over. We want to get as much data as we can on this capsule so that we can track it and independently confirm the orbit. How cool is that? Humans heading to the moon for the first time in over 50 years. 4 astronauts on board the Orion capsule Integrity. Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, Canadian astronaut Jeremy Hansen. Heading to the moon right now on a free return trajectory, and here we have it from Florida in an 11-inch telescope. So the telescope in Chile right now is taking pictures of these same coordinates. At the very least, we should have strong confirmation that this dot is not exactly where we see it here in Florida, but hopefully it'll be somewhere in the frame of the telescope in Chile so we can directly measure the parallax. Independent tracking here, using just my own previous observations and my estimation for TLI, and then searching around till I find it. How did I get the coordinates? By taking the orbital elements that I calculated from my first set of observations, loading that into Orbiter Spaceflight Simulator with a simulation of the capsule, and performing the TLI burn when it reached perigee, and setting it up in Orbiter using the TransX MFD to create a free return trajectory just like they're really doing, and then looking where that would be in the sky. It was a bit off. We had to search around, but we found it. Where am I at in Florida? I am south of Tampa. Hey, Arnold. Good to see you. Yeah, ultimately I will produce a time lapse of Orion like before. This time it's a much smaller streak. In fact, it just looks like a star in individual exposures. You really have to look and blink across multiple exposures to see the motion now because it's so much further from Earth. Hey Renee, good to see you. Thank you, Calder. Okay, looks like the telescope in Chile finished up its observations. Wonder if they sent me thumbnails to my email with the receipt. Looks like I haven't received the receipt yet. But hopefully I'll get it shortly. Yeah, they're done with the TLI burn. They've been done for a while, and they're just letting Sir Isaac Newton take the driver's seat. At this point, they've passed the halfway mark, and they're most of the way to the moon, but of course they're decelerating under Earth's gravity. But the moon will redirect them and send them back to Earth on a free return trajectory. Their closest approach to the moon should be on Monday. When Artemis go near moon, like in front of it, don't forget to get that rare picture and share with us how it looks like, okay? It's not going to go in front of the moon. It's going to go behind the moon. And even now, the moon's getting closer to it. Really, the funny thing is, it's decelerating as Earth's gravity continues to pull on it, and the moon's just orbiting Earth. It from a perspective centered on the Earth, it'll look like the moon is doing a drive-by of the capsule. But the moon is getting closer to the capsule over time, and at some point, the glare from the moon will probably blind the telescope so much that I won't be able to see it anymore. Thankfully, I can still see it tonight, despite how far away it is. Oh, looks like I got my usage receipt. It didn't come with the thumbnails. That's fine. I'll just download the data directly. Give me a second. That was T72. First 3 pictures are available for download. That should be enough to at least see if something's going on there. I'm gonna load up those pictures from Chile. Hopefully we get something good. Hmm. Maybe it'd be easier in Deep Sky Stacker. These frames from Chile are really high resolution. My poor old camera is not nearly as high res. Hmm. Yeah, I don't see it. I fear it may be out of the frame in Chile. I think the parallax is too severe. Shoot, shoot, shoot. Well, that's okay. We've got it here in Florida. And once I get the orbit solved, I can gather more observations from other telescopes. Did I recalculate the coordinates for Chile? Yeah, it's more than a degree of parallax. Um, and I'm trying not to cheat with JPL Horizons. I'm trying to do this purely myself with independent tracking. But yeah, you're right. Like it's significant and it's too significant. Unfortunately, that telescope's field of view is not wide enough. I do wonder if it would have to be a balance of telescope size, field of view, all that kind of stuff. That's not the right one. What's the deal? T75, okay. And the field of view there's better. 1.5 degrees. Well, still, I should probably hold off till I get actual orbital data and then confirm. But yeah, Orion's moved off well to the side in these images, and it's still moving. What part of Florida is this from? The west coast of Florida, south of Tampa. Yeah, I could estimate the parallax using some range and geometry. That's true, but you haven't accounted for the fact that I haven't slept. It's now 4 a.m. and I haven't slept in almost 24 hours. Is this channel directly connected to NASA? No, no. In what part of the sky is Artemis right now? Scorpius. But it is extremely faint, even to my 11-inch telescope. So you definitely wouldn't be able to see it by eye. Thank you, Flycam DFW. Appreciate it. I'll see if I can make a quick and dirty time lapse without calibration frames here. I still have the dust motes, which, by the way, the dust motes are those black donuts in the frame. But I will try to process these into a quick and dirty time lapse of all the frames we have so far. Oh, yeah, this is gonna look cool. Real cool. Okay, let me try to redo the contrast on that. It's better. Okay, it's good settings on contrast. I just need to grab the latest images. Okay, cool. Hopefully the resulting video that it saved is good and working. Yeah, that looks good. Okay, now I'm going to pull up a time lapse of all the frames we've collected so far since we found it. Check this out. There it is. Moving along in the time lapse. How cool is that? How cool is that, guys? How far away? Well, they're supposed to be more than half the distance to the moon now. I'll have more exact figures once I get some measurements done here and solve for the orbit. Whole bunch of dots. So there's some hot pixels that remain unsubtracted. The rest of the dots are stars. The ones that are slightly wobbling from the telescope tracking. The ones that don't move at all, those are hot pixels. Okay, I think after this exposure, I'll move the telescope so that Orion is more centered again, and we'll get a new segment. Okay, I'm moving the scope, hopefully recentering Orion. The live image in the background behind the animation should streak quite badly. Yep, there you go. Scoot it a little more. I think it's close to one of the dust motes now. Let's see. Well, maybe not, but still. Okay. Yeah, okay. Now I've got a little left of center and it's moving up and to the right. So I'll let it continue to track through the telescope. So if I go back to the live image, the new position of it is here in the frame after I moved the telescope. Best I can tell. Where's the moon in the sky? It's up and to the right of where Orion is in the sky. Yeah. Yeah, guys, this is a dream come true for me. Being able to track a crewed spacecraft on its way to the moon. First time in my lifetime. Well, I'm glad you did find this stream now, there, George. Appreciate your being here. So yeah, if anyone's just joining, this is a time lapse of the first positioning we had when we first found Orion. And you can see it moving there from center up and to the right. And now we've moved the telescope And we're going to collect more images for part 2 of the time lapse, basically until morning twilight hits. One second, I'll be right back. All right, I'm back. Yeah, it's the time lapse is on loop. And yeah, I found it. So on the grainy image, the very grainy image in the background on the left, that is the live image. And I've got the caret pointing at where it is currently, where Orion is currently in the live image. And on the right is the replay of the time lapse. Yeah. Apologies for any background noise here. Okay, hopefully I can record a little long exposure of my telescope as it tracks Orion. Maybe get the moon in the frame too. So, in what software can you visualize the current position? If you go to JPL Horizons, you can get the data from NASA directly. It's in Scorpius, but it's very, very faint. Requires significantly powerful telescope to detect. I've got an 11-inch scope here with a CCD camera bending the images 2 by 2 for enhanced sensitivity. But if you have the orbital elements from NASA, then you could probably load it into any program like Stellarium or Sky Safari, etc. But yeah, what I'm trying to do tonight is independently track it, independently determine the orbit. But I will post a link to JPL Horizons for anyone who wants to get the data directly from NASA and find out where to point their telescopes to see it. So you can go on Horizons, set your location, search for Artemis, and pull the coordinates directly. I decided to hunt for it myself based on my own tracking of Artemis. Where's the moon in the sky? The moon is off to the right and up. It's, probably about 30 degrees out of the field of view at this point. So yeah, that little moving dot, 4 astronauts on board headed for the moon. Can I get the moon in frame? Not, not even close. The field of view here is about 1/3 of a degree. So figure less than the size of the full moon. And the moon itself, it's got to be at least 15, maybe 30 degrees away from where the telescope's currently pointing, just eyeballing it. It would take many, 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 many fields of view to get over to the moon. If I wanted to make a panorama out of it, I could just move the telescope over there, but then we would lose Orion. Yeah, it's the same clip over and over. On the right is a time lapse of the first part of this stream since we found Orion. And we're now moving the telescope. We've moved the telescope and we're tracking it again, as you see in the live image on the left. That little caret is pointing at the current position of Orion. How far away are they now? Over half the distance to the moon. All right, see you, Renee. Have a good night. Where am I streaming from? Florida, south of Tampa. Do I think it'll still be possible to track it with the C-Star S50? Maybe. It's not the faintest star in the frame here relative to the stars you see here. Like, you can see it's brighter than the faintest stars that my telescope can pick up. So maybe a C-Star could detect it. But at this time, at this distance, I feel like it would be really tricky. If you were direct tracking it with C-Star, then maybe yes. If you were doing what I'm doing and just tracking the stars and letting it streak through, the signal-to-noise ratio would be pretty tricky. I mean, this is an 11-inch telescope. On the other hand, the CCD camera I'm using is quite old. It's not the most sensitive or highest-end detector, so that could play in the C-Star's favor. So I can't rule it out at this point, but I wouldn't bet money on it. Now, it definitely could earlier in the mission when it was closer to Earth. And I think I've seen at least one picture with a smart scope that picked it up. But I think that might have been last night, or at the very least much earlier tonight. But, well, it couldn't have been much earlier tonight. It hasn't risen. It hadn't risen yet in San Francisco where the picture was taken. So it must have been last night, at least. So yeah, when it was closer to Earth, definitely. But now, it's a pretty tricky target. I'm gonna let it streak through and then do the time lapse. Yeah, I mean, go for it. I'd be curious to see. I'd be impressed. I mean, again, I don't think it's out of the realm of possibility, but this is not an easy target at this point. How did I find Orion? So I had tracked Orion a couple nights ago during the early phase of the mission when it was still in an elliptical orbit around Earth before they committed to TLI. I took those observations, which included observations from both my telescope here in Florida and another telescope in Utah, and solved for the orbit. I loaded that orbit into Orbiter Spaceflight Simulator with a simulation of the Orion capsule, and I simulated the TLI burn myself to see where it should end up in theory if it's headed for the moon with a free return trajectory. I then pointed the scope at those coordinates, didn't find it right away, but we searched around, and it wasn't too far off, maybe a few degrees, maybe not even a few degrees, maybe about a degree from those coordinates. And here we are. We have Orion. So, yeah, pretty cool. Of course, you can pull the coordinates directly from JPL, but what's the fun in that? I wanted to see if I could fish around and find it starting from coordinates that I predicted myself based on my own previous observations of the capsule. Now that it's in a free return trajectory, the trajectory is not going to change very much between now and splashdown, so keeping up with it from this point on is not difficult at all. Yeah, it's quite low for most people in the northern hemisphere. Even from Florida, it's 30, 35 degrees. Not that bad, but not spectacular. And because it's low in the south, I had to put my scope all the way at the far north end of my lot and back it up against the trees, basically, so that I could get the maximum clearance over the trees to the south. Here it's 10 degrees or below. Yikes, yeah. Southern hemisphere has a much better visibility. So if you're in the southern hemisphere, you're in luck. You'll have a much easier time keeping Orion above your horizon. Turn down the gain a little bit. I'm maxing out the mic at times, but Can I update the time-lapse on the right side? Yeah, I mean, I could. I don't know if I have enough images just yet to really make it great, but we can. I suppose I could just append it to the previous time-lapse and it'll just shift positions suddenly. But that might not be so bad. See, we left off at frame 191 there. And we'll get all the rest of these frames. Yeah. All right, so I'll update the time-lapse here. Give me a second. Okay. Here is the updated time-lapse. Again, I just appended the new frames to the old frames, so suddenly the position of the telescope changes, and so does Orion as a result. Which is a bit jarring, maybe, but hopefully not too bad. So here's the new position. Now it comes out of the left and goes into the center, just above center, really. There it is. And then it restarts on the first part of the time-lapse. The sparkles, you mean the grain? So there's some grain just due to camera noise, just thermal noise of the camera. There's little brighter specks that are cosmic radiation hitting the CCD. The bright transient specks that only appear for one frame, those are cosmic ray hits. And then the bright dots that are always there are just effective pixels, hot pixels. Hello from Spain. Thanks for joining. Well, even a 4-inch refractor might be something you could try to use to detect it. It seems like that might be a bit small in terms of aperture, but again, my sensor is also old and not super sensitive. And the 11-inch here isn't having, much difficulty detecting, as you can see. So maybe even a smaller scope could eke it out. It would just be fainter and closer to the noise floor. So we're coming up on 5 o'clock. We got about an hour left until morning twilight. And of course, I'm going to try to keep getting as many images as I can here. Have I ever noticed differences in frequency of visible scintillation during solar flares? No. Have I ever, with my equipment, observed gamma ray bursts? No, I haven't had the opportunity to look at a afterglow of a GRB. That would be cool. Differences in scintillation during solar flares. That sounds interesting. I haven't observed that before. But then again, I haven't been looking for it. Looks like T68 is available. It's a free scope on itelescope.net if you have a membership. 2.2 by 1.46. I'm gonna chance it. I'm gonna try. Where are we at here? I'm gonna try feeding it the coordinates I've got right now, without accounting for parallax. It's got a fairly healthy field of view, 2.2 by 1.46 degrees, so pretty generous field of view. And hopefully that will be enough for me to do the lazy thing and just give it the coordinates for my location right now. Access there. Let's see, position 268. Gonna try to update the time lapse again. Let's see, I don't know if that'll dynamically add to it on the fly. Oh, it does. It does. Very nice. Okay, cool. Come on. Come on, my telescope. It won't let me use it. Okay. Apparently I've used it too recently. Oh, that's a shame. Try differently. Oh, it won't let me. Oh. I guess it considers me done for the night. I can't even pay for a session. That's crazy. Thought it would let me. Okay. Let me try that. Create plan. Run plan. Won't let me do that. Doesn't seem like it's going to. Yeah, no, it won't let me. Oh, that's a shame. Have to come back and do parallax another night. Alright, in the meantime. See if I can update the time lapse again. Hmm. That's peculiar. 10 times. Did I accidentally reset the index? Oh, I don't love that. Oh, I accidentally moved the frames? Or something? Huh. No. Not quite understanding what I did here. Oh, I see. No, wait, do I not see? I don't see. Even 12. Okay, great. Huh. Yeah, I'm not sure what's going on with the index numbers. They're kind of screwy to me. I'm going to try recreating the time lapse from scratch in a new directory. Yeah, let me create this new one. Okay. Alright. Now I'll load up the new time lapse. I don't know why the index numbers seem to change between directories. That was weird. But the images are all still there. They're just differently indexed in the two different directories, even though I didn't rename them. So that shouldn't have happened. But whatever. It is what it is. Okay, so now the time lapse is updated with all the images we have so far. There it goes again through the field of view. Cool stuff. How far is it from Earth? over half the distance to the moon. I'll have exact figures once I measure the orbit for myself. Why is my telescope shaking? Because I'm not guiding. This is unguided. It's not locking on to any stars. It's just open loop tracking, essentially. And it's in altitude azimuth mode, which is less accurate by its nature. So it's just roughly tracking with the rotation of the Earth and trying to track the stars. But because it's out as aligned, it is not aligned parallel with Earth's axis of rotation. So you get field rotation, even if the tracking were perfect. And it is most certainly not perfect. You've got two different motors, each with their own periodic error. And so you end up with a bit of wobble. But that's okay. I still think the view is rather incredible. Yeah, I tried to shoot in Chile, but I missed. I didn't account for parallax. I knew it was going to be significant, but yeah, it put it completely out of the field of view. So I'll have to try again with maybe Chile on another night. Once I have the orbit, I can easily uh, produce an ephemeris for different observing sites. Hey, Tori. Yeah, we're having a good time tracking Orion here, on its way to the moon. We've got about 40 minutes till astronomical twilight, so... Yeah, the moving dot is Orion. There. Hopefully that helps people who might just be joining. So yeah, I'll continue to update this time lapse as more images come in until we hit twilight. This clip is being captured as we speak, so again, I am updating this time-lapse with new images as I get them. Each image is a 20-second exposure. And it's rendering a new version right now with the latest 19 images that we added to the time-lapse just now. Thanks! Thanks, Geese Howard. Appreciate it. Yeah, I really had a lot of fun tracking that launch. And now here we see the capsule in deep space with the very same telescope that did the launch tracking. So now the time-lapse is extended a little bit on the second part. The first part is where it starts near the middle of the frame and moves to the outer right edge. The second part, after I reposition the telescope, has it to the left of center, moving through the center, and now up and to the right. Am I going to sleep at all before Monday? Well, yes. I will probably be sleeping in a little today. The spacecraft is the moving dot. The black things in the middle are dust motes on the CCD. They'll be taken out in the end with flat field subtraction, but until then, these are uncalibrated frames. I will be right back, folks. I'm back. And I will update the time-lapse once again. Alright, here we go, rendering a new version of the time-lapse. A little bit of passing cloud cover near the moon. Okay, now the time-lapse should be updated with the latest images. Yep, looks like it. We got just about 24 minutes left until astronomical twilight, at which time I'll be wrapping up the webcast. But don't go anywhere, I'll be right back, and extending the time-lapse even further. Oh, the field of view is about 1/3 of a degree wide. What direction is my telescope aiming? It's aiming in the constellation Scorpius. Current right ascension declination in J2000 coordinates is 16 hours, 9 minutes, 1.9 seconds, and declination negative 27 degrees, 17 minutes, 49.7 seconds. I'll refresh the time lapse again. Okay, here's the refreshed time lapse. So again, Orion is the moving dot starting out in the center and moving out to the right. Now, at this point in the time lapse, I've repositioned the telescope. Orion is again moving through the center and moving up and to the right in the frame. It's moving left to right, yeah. All right, here it is with the cursor. To help you see it better. Spacecraft is a dot moving from left to right in this time lapse. Here it is at the beginning of the time lapse, and I'm adding to this time lapse as more images come in. And then it comes over here. So in the middle of the time lapse, I repositioned the telescope. Okay, hopefully that helps. Hey, Christopher. Yeah, so we found Orion on its way to the moon. And I've put the frames that we've got so far into a long time lapse. And you can see it moving here from left to right, up and to the right. And then the time lapse resets, and it starts out in the middle, moving up and to the right until I reposition the scope. And again, it'll be left of center after the reposition here. And it comes over here and moves up and to the right. Oh yeah, you could definitely get it with a 14-inch. I'm doing this with my 11. Yeah, there's no guide star. This is just unguided exposures. I mean, most satellites don't move like this. Most satellites are much faster. Even geostationary satellites will move much faster than this relative to the background stars. So this is kind of unique. And as far as asteroids go, most asteroids don't move this fast unless they're near-Earth asteroids. So if this were a naturally occurring asteroid, you might want to take a careful look at the orbit and make sure it's not going to hit Earth. In fact, it is going to hit Earth after it goes around the moon on a free return trajectory. Just so happens it's not an asteroid, it's a crewed spacecraft. In the constellation Scorpius, the exact coordinates will depend on your location. I hunted for it based on my own determination of the orbit and my estimation of TLI, but that was just me doing things independently of NASA for reasons. But if you want to just get the coordinates from NASA directly, here's the website for JPL Horizons, so you can go request the coordinates for your location. Yeah, my FOV is pretty tiny as well. This is about 1/3 of a degree wide. This sensor is not the largest, for sure. So yeah, there you go. The Orion spacecraft integrity on the way to the moon. Hey, Christopher, if you get some images of it, please share them with me. I would love to do a parallax measurement. Assuming you can get on it. Does it have a solar panel array? Yes, it has 4 different solar wings, and they provide electrical power to the spacecraft instead of the fuel cells that the Apollo command and service module used. I don't know the code off the top of my head for it in JPL Horizons. I just do a search for target. I just search for Artemis 2, or just Artemis even. It'll offer it up as a suggestion if you want to get them that way. Like I said, tonight I didn't do it that way. I just hunted around based on my own calculations of where it ought to be, knowing that it's doing a free return around the moon, and based on my own previous observations of it. How long is the time lapse? Let's see. Let's see, we first found it at... 3:45 a.m. So yeah, we're hitting 2 hours now on it. And speaking of, I'll go ahead and add the latest images so it'll officially be a 2-hour time lapse. Eight. Yeah, I haven't played around with Arrow. I like JPL Horizons because you can request it neither apparent coordinates at the epoch of date or J2000 coordinates as you prefer. Maybe Arrow has that capability too. I don't know. I haven't played around with it very much other than to just quickly look at it and sort of appreciate the visualization. Almost reaching the edge of the field of view now at the end of this 2-hour time lapse. Now with the updated images. Where is it? It's a dot moving left to right in the frame. I'll highlight it for you here. Right here. This is the second part of the time lapse after the telescope was repositioned. Yeah, I invited a space denier to come remote control my scope tonight. He ultimately declined my invitation. But I still have it out there. It's an extended offer for anyone who thinks that I'm faking this. I'll let you remote control the scope and the camera, and you can see for yourself. No, it was not Mikey Smith. Mikey's welcome to do it as well, but no, in fact, it was a guy by the name of Terry Hafner. Never really heard of him before Artemis, but yeah, he said he was going to do it, and he didn't want to get on Discord so I could chat with him while he controls the scope. I need to be able to communicate with him. And he definitely didn't want to do this at 4 a.m., which, well, that's the nature of the beast. It's visible only in the early morning hours, so if you're not willing to come watch it in the early morning hours, you're not going to be able to watch it live. I can't control that. It's just how it is. So, but I want to thank you all for coming here in these early morning hours for those of us here on the East Coast and watching this live stream of Artemis 2 heading for the moon from my own telescope in my own yard here in Florida. Same telescope I used to film the launch. We're going to be hitting astronomical twilight here in about 4 minutes. So, as I said, I'll be wrapping up the stream at that time. Oh, thank you, Christopher. No, if you get some images, I'd like to measure them astrometrically. Yeah, the moving dot is integrity. That's right. Tomorrow? Well, let's see. Other than the fact that I will be dead dog tired, yeah, tomorrow could be a tricky one. Ooh, weather-wise. Ooh, oof, oof. Yeah, tomorrow might actually be the last opportunity weather-wise. At least for me. So I will make the best effort I can. So it's on a free return trajectory, therefore, other than minor course corrections, it's going to stay on the current orbit, and we can predict where it's going to be in the future based on its current trajectory. Do I ever get an existential crisis watching so many stars? No, not really. Sometimes when I'm manually looking through the telescope to look for something in the eyepiece, there's almost this sense of existential dread, I guess, of just seeing all these stars and not knowing what's going to show up around the corner. You just never know what you're going to find. And I don't know, there's no real rational reason behind it, but moving the scope around, it's kind of breathtaking in a, I don't know, almost anxiety-inducing way of just, what if I see something new? What if I find a new comet that no one's seen before? I've only ever done that once, quite serendipitously, and not even with my own telescope, but still, it's an interesting feeling. I don't really get that from photography, though, from doing any astrophotography. It's just something I experience only when looking through the eyepiece. Yeah, I discovered comet P2016 J3, which was recovered in, was it 2020 or 2021? I think it was 2020. And it was given the permanent number designation 414P, because it was now seen on more than one orbit. So 414P stereo is a comet that I discovered back in 2016. So again, here is the Orion spacecraft headed for the moon. I'm going to process what will be the last of the images of it for tonight. In just a minute. Which is perfect timing because it's almost right at the edge of the field of view now of the telescope. So position number 2 is going to be the final position for the pointing of the telescope at Orion tonight. Yeah, sorry, Topflix, but don't worry. The recording will be available, and yeah, feel free to go back and watch. But really, the nice thing about the time lapse is it shows you the whole course that it took through the course of the night as we've been recording it and watching it here on Astronomy Live. And now at 5:58 a.m. Eastern Time, we are officially entering astronomical twilight. So I'm going to stop the imaging there and go ahead and update it with the final images. All right, rendering out the final time lapse. All right. Now that's the final time lapse, but for those of you who've stuck around to the end, one last thing I'm going to do, foolish though it may be, I'm going to point the scope at the moon, and we'll try to take a quick look at the moon, hopefully without blowing out the camera completely. So I don't know if this is going to be too dim, too bright. There we go. There's the moon. So yeah, these very fast exposures now, as you can see, you can't see the stars because we're running an exposure of 0.001 seconds. That's how sensitive this camera is. Before we were doing 20-second exposures to see the stars. So there you go. As you can see, we can't fit the whole moon in the frame. Not even close. Oh, I forgot I needed to turn off the... There we go. I still had the time-lapse over the moon. But there you go. So here you can see the moon without the time-lapse blocking it. And yeah. It's a nice moon, but you can't even fit the whole moon in the frame of this telescope with this camera, even with the focal reducer. Tweak the focus just slightly here. Ow! Ow! Knocked my flashlight over. Well, that's pretty much going to do it for tonight. Which magnitude was the Orion? Ooh, that's a good question. I would estimate magnitude 14 or 15. Might have been dimmer than that, but it was pretty dim. But I'm just guesstimating based on the relative brightness of the stars. When was that Orion footage taken? Throughout this whole webcast. I was continually adding to that time lapse as we were recording images. Does the full moon make it difficult to record the dim Orion? Not yet, but it will. By tomorrow, we'll see how much I can see, if I can see it at all at that point. Can I see it in Australia? Yeah, you should be able to. Was it ever a binocular object? Well, I suppose it would have been when it was close to Earth. And when it was in the initial elliptical orbit, maybe. But definitely not now. So yeah, that's going to do it for tonight's webcast. Thank you again for everyone for coming and watching and enjoying the view of the Orion capsule Integrity heading for the moon with Commander Reed Wiseman, pilot Victor Glover, Christina Cook, and Jeremy Hansen. Until next time, thanks for watching and clear skies.